If you love space science and astronomy news, check out my 60-second short videos every weekday. In case you missed them, here's all the daily videos in one cut. There was a ton of great stories this week, but of course there's a ton more out there just waiting for you to discover them on your own. Check out this incredible Einstein ring discovered by the Euclid Space Telescope. Einstein rings are a prediction of general relativity and are caused when light from a background galaxy passes close to a massive object on its way to observers here on Earth. The mass of the foreground object, usually another galaxy, distorts space-time, creating a gravitational lens that makes fractured images of the background star or galaxy appear in unexpected parts of the observed region. Sometimes crosses or zigzags form, and very rarely full rings like this one. Rings are rare because they require the background and foreground objects to be perfectly aligned with the observer on Earth. The foreground galaxy here is NGC 6505, which is only 590 million light years away, while the background galaxy is around 4.4 billion light years away. By studying the structure of the lens, astronomers are able to estimate the mass and other properties of the foreground galaxy, giving them valuable information about the dark matter content of NGC 6505. ESA's Euclid was launched in July of 2023 and is building a 3D map of the universe and discovered this Einstein ring by coincidence. Euclid will survey about 14,000 square degrees of the sky and expects to find only about 20 full Einstein rings like this one, although it should see over 100,000 of the other types of gravitational lenses. The research was published today in the journal Astronomy and Astrophysics. Today is the 10th anniversary of the International Day of Women and Girls in Science. I'm personally not enough of a snowflake to think that acknowledging the amazing contributions of women in science in some way diminishes the contributions of the many other scientists out there. Often these women have had to overcome incredible hurdles to achieve their dreams of being scientists, and that struggle continues to this day, even if some people would prefer not to acknowledge it. Take Marie Curie, who did pioneering work on radioactivity, becoming the first woman to win a Nobel Prize, the first person to win a Nobel Prize twice, and still the only person to win a Nobel Prize in two scientific fields. There's American mathematician Katherine Johnson, who was a computer at NASA, a literal rocket scientist, and Jane Goodall, who is considered the world's leading expert on chimpanzees. And those are just three quick examples. There are other women, far too numerous to mention, stretching back all the way to the astronomer Agassiz in 1900 BCE, through greats like Vera Rubin, to modern-day leaders like Marcia McNutt, the first female director of the USGS, and Maybrit Moser, who won a Nobel Prize in Medicine. Let's not forget the women scientists just around the corner who are your local veterinarians or physicians. Jump over to the Wikipedia entry called Timeline of Women in Science and take a few minutes today to appreciate all of the amazing women who have helped us bring our knowledge of science to the incredible place where it stands today. And to all the women scientists out there, we see you. Thank you so much for your hard work and dedication. Did you know there's an astronomical detector submerged 3,450 meters below the surface of the Mediterranean Sea? The Kilometer Cubic Neutrino Telescope, as its name suggests, is looking for neutrinos, or so-called ghost particles. Neutrinos are one of the hardest particles to detect because they have no charge and almost no mass. Scientists build large detectors not to see the neutrinos themselves, but to detect other particles that result from interactions of a neutrino with matter. By studying the trajectory and energy of the particles, scientists can infer the properties of the original neutrino. KM3Net has just announced the detection of a neutrino 30 times more energetic than any other neutrino ever detected. An observation like this gives us a window into the highest energy phenomena in the universe, and it's possible this neutrino was created when an ultra-high energy cosmic ray interacted with the cosmic microwave background. This detection was actually made in 2023, but the painstaking process of analyzing and checking the data took a while, and the article was just published in Nature. KM3Net is still under construction, and this detection was made with just 1/10 of the final number of detectors, so it'll be exciting to see what the full array will be able to do. Water is an essential ingredient for life as we understand it, and NASA is launching a new mission to hunt for water outside our solar system. The SPHEREX mission, which stands for the pretty awkward Spectrophotometer for the History of the Universe, Epoch of Reionization, and ICES Explorer, is scheduled to launch towards the end of this month aboard a Falcon 9 rocket. The mission will perform a large-scale search for water, carbon dioxide, and carbon monoxide frozen to the surface of interstellar dust grains. These tiny dust grains form huge molecular clouds in the space between stars. These molecular clouds are often beautiful to look at in images, as you can see here, but in addition to the eye candy, we think they also contain most of the water in the universe and were probably the source of all the water on Earth. SPHEREX will take 3D data along the line of sight through the cloud and build up a picture of ices throughout the cloud. Since stars and planets form inside these molecular clouds, a detailed understanding of the distribution of ices should give scientists new insights into star and planet formation and answer some outstanding questions we have from previous missions to study molecular clouds.